Alrighty, welcome back to another state test prep video. Today we're talking about standard 7.SP.2. This is our second statistics and probability standard. So here we go. Alright, question 1. A pizza shop wants to determine how often it delivers to 3 different areas of a city. The table shows the areas from a random sample of 80 deliveries. Based on this data, if the driver makes 200 deliveries, how many deliveries will be to the southern area of the city? Okay, so here's what we want to do. Okay, first, we want to find out what percent of deliveries went to the southern area. So how are we going to do that? We're going to take 22, and we're going to divide it by how many total deliveries were made. So 14 plus 44 plus 22. I'm going to assume we have a calculator for this, so we're running with the calculator. 14 plus 44 plus 22 is 80. So 22 out of 80 went to the southern area. Now we need to figure out what percent that is. So divide 22 by 80. And you get 0.275. So 0.275, or 27.5% of deliveries, went to the southern area. So now we're going to use this data to predict, okay? So 27.5% of deliveries went to the southern area, and we're making 200 deliveries. We're going to do 0.275 times 200. That means 55 would be what you expect to go to the southern area. So we found out what percent by taking the amount that went to the southern, dividing it by the total number of deliveries. That gave us 0.275, multiplied that by how many deliveries they're going to make, and that gave us what's called the expected number. Dan surveys 10 of the 24 students in his class about the number of people and their families. The results of his survey are given: 3, 3, 4, 3, 6, 5, 7, 3, 4, 2. Based on the results of Dan's survey, what would be the best estimate for the mean number of people in students' families? So remember, you learned a lot about mean, you learned about median, and you learned about mode. These three are always talked about together. Okay? The mean represents the average. The median represents the middle. And the mode represents the most frequent. So, to find the mean, you need to take the sum of all the numbers and divide that by how many numbers there are. So here, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers. So whatever we get, we're going to divide by 10. So, let's add up these numbers. 3 plus 3, calculator's allowed, right? Yep. Plus 4, plus 3, plus 6, plus 5, plus 7, plus 3, plus, whoopsie, plus 4, plus 2, and that is 40. So 40 divided by 10, I could tell you it's 4, but just in case you want to confirm in the calculator, it is 4. So the answer would be 4. Add up all the numbers, divide by how many numbers you have. Question 3. Keely is trying to find the average weight of an apple in a crate of 50 apples. She picks 10 apples at random, records their weights in ounces. The weights are given. Based on this sample, what is the mean weight in ounces? Round to the nearest tenth. So again, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 apples. So we're going to end up dividing by 10. Now we just need to find the sum. 8 plus 9.2 plus 9 plus 8 plus 11.4 plus 12.1 plus 14 plus 15.6 plus 12.6 plus 8. You just gotta be, for questions like this with means, I would encourage typing the numbers in twice just to make sure you didn't typo somewhere. I'm only going to do it once because I literally watch the numbers go in, but just make sure you're paying attention. Then we're going to divide that by 10. That gives you 10.79. So 10.79, we need to round to the nearest tenth. Remember, the tenth is one spot after the decimal place, so this number will either round up or down based on the number to its right. Remember, with rounding, 5 and above, give it a shove. If it's below 5, 4 and below, you round down. So 5 and above, give it a shove is the way I always remember it. This is 9, that's more than 5. So you're going to shove this up to 10.8 ounces. All right. Question 4. Mr. McGregor had 28 students in his class. He selects 10 students and records their height in centimeters. The height of each student is shown. Based on the sample, what is the best estimate for the median height of his students? So, median. Median is the middle, okay? However, you can only calculate the median if your values are listed from least to greatest. Your values have to be listed from smallest to largest. So, we have to put these in order. Here we go. My lowest number appears to be 140. Once I use it, I cross it out so I know that it's been used. What's next? 151. 150 is the smallest. So 150. Then we go to 151. That would be next. 151. Then 153. There's two of these. 153 and 153. Then we have 157. Then we have 158. Then we have 160. 164. And 184. So now to find the median, you cross out from each side. So I take one off the left, one off the right. 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 Now, if you get to this point and there's only one value left, that value is your median. But we're at the point where we did that and we have two values left, 153 and 157. In this case, you find the average of the two. 153 plus 157 divided by 2. No calculator allowed, that's fine. 153 plus 157 would be, I'm going to focus, 3 plus 7 is 10, carry the 1. 5 plus 5 is 10, plus 1 is 11, carry the 1 again. 310. Then we have to divide 310 by 2. Here we go, long division, 310. 2 divided by 3 is 1. 2 times 1 is 2. 1 comes down. 2 divided by 11. The highest you can go is 5. 2 times 5 is 10. 1 drops down. Or, yeah, 1 left over. 0 drops down. 2 goes into 10 5 times. 2 times 5 is 10, so we have no remainder. Our answer, our average, is 155. Let's go to question 5. The population of Drumville is 4,086, and the population of Cardington is 3,812. Brian surveys a random sample of 400 people from each town about their ages. His results about the samples are given. Drumville has a mean age of 36 and a mean absolute deviation of 10. Cardington has a mean age of 49 and a mean absolute deviation of 8. What conclusion can be made about the two populations? Is it A, no conclusions can be made because the sample sizes are too small? B, no conclusions can be made since the mean absolute deviations are not the same? C, there is generally more variability in ages in Cardington than there is in Drumville? Or D, the people in Drumville are generally younger than the people in Cardington? So mean absolute deviation is a measure of variability. The idea is that your ages are closer to the mean, excuse me. If your ages are closer to the mean, your mean absolute deviation will be lower because there is less variability. Okay? Someone with ages of 1 and 50 will have a higher variability, a higher mean absolute deviation than someone who is 25 and 27, if the mean is 26. However, what you can infer is knowing that mean means average. Drumville, average age is 36. Cardington, average age is 49. You could make the assumption, it is a reasonable assumption, you can make the assumption that the people in Drumville are generally younger than the people in Cardington. Why? Because it's not like it's a difference of 36 and 37. This is a difference of 36 to 49. That's a 13-year difference. That's significant. Question 6. Calculator allowed. Amanda finds that a random sample of 120 students at her school, 42 students own a cat. Based on this data, oh my God, I hate that, grammatical errors. Based on this data, what is the best estimate for the percent of students who own a cat? Find a percentage. Take how many fit the rule. How many people own a cat? 42. Divide it by amount of people surveyed, 120. Equals. You saw that go away that fast too, right? 0.35. That gives us a decimal. We need to convert that to a percent. So we talked a lot about converting percentages to decimals by grabbing the decimal point and moving it 2 spots to the left. To convert a decimal to a percent, you grab the decimal point and move it 2 spots to the right. So this would be 35%, which is A. Even if you can't remember how to do that, by the way, you can eliminate choices on this question. You can tell that half of 120 is 60, because half of 12 is 6. So you know that 42 is less than 60, right? So anything over half, C and D, would be immediately eliminated. So even if you can't remember how to get to 35%, eliminating choices makes this a 50-50 guess instead of a 25% guess. All right, so that's going to do it for this standard. I'll be back for another standard. Until then, thanks for watching, and good luck on your test.